Calling on Engineer Victor Akpatim to lead the recap. Engineer Victor Akpatim, please.
Good morning, everybody. Good morning, Director. Thank you very much for this privilege. Thank you, Director 2, and the Dam Department as a whole and the Ministry for this privilege to come and learn what we've been craving for a long time. Before I go into the recap, 1 minute of a very strong personal note. I'm from the Department of River Basins Operations and Inspectorate. And we have some dams that we call RBDA dams. So since 2018, I joined Ministry 2017, we created, as an inspectorate department, what we call development of guidelines for operations and maintenance of RBDA dams and irrigation infrastructure. 2023, we upgraded it to operationalization of RBDA dams, guidelines, and the rest of it. We even had what we call RBDA Dam Safety Inspection and Surveillance. I happened to work on all this for this number of years. But I'm so humbled to stand here and say that yesterday's workshop turned me to a dams baby. I was writing notes and typing and recording all the lectures, and it has made me as a person, and by extension, I think my department will benefit maximally from yesterday's workshop for the expository knowledge, the depth analysis by Dr. Marvin, Dr. Eduve, and everything that happened here yesterday. It was like a PhD lecture. Thank you very much, sir, and thank you, the organizers. Now, the recap of yesterday. Workshop on dam safety management held at Global Village Suites and Conference Center, Maraba Kefi, Abuja Road, Nasarawa State, from 26 to 27 June 2025. Recap of proceedings on day 1. The workshop on dam safety management held at Global Village Suites and Conference Center, Maraba Kefi, Abuja Road, Nasarawa State, commenced on Thursday, 26 June 2025. Participants at the meeting included directors and staff of Federal Ministry of Water Resources and Sanitation, representatives from the Federal Ministry of Power, National Water Resources Institute, representatives of State Ministry of Water Resources, River Basin Development Authorities, resource persons, and the press. A total of 121 participants were in attendance physically, while 37 attended virtually on day 1. The event began with a citation of the national anthem, which was followed by opening remarks by the Director, Dams and Reservoir Operations. Goodwill messages were received from representatives of the Federal Ministry of Power and National Water Resources Institute, Kaduna. This was immediately followed by the keynote address by the Permanent Secretary, Federal Ministry of Water Resources and Sanitation, who declared the event open and encouraged active participation by all present. The lead paper on dam safety management in Nigeria was presented by Engineer Daisy Alabi, where he proposed development of a dam safety, don't worry, I'm okay here, thank you. Where he proposed development of a dam safety management system, DSMS, guidelines and risk-based approach, training and capacity building, emergency action plans, EAPS, and as well as regulations as measures to ensure dam safety in Nigeria. Afterwards, vote of thanks was given by Director 2 from the Department of Dams and Reservoir Operations. 3 technical papers were presented during the technical session. The first paper was Overview of Spin Project and Dam Safety Component by Engineer Ipilaye Olaya, ably represented by Engineer Mina Imam Binuyo. The paper opined that success of SPIN project depends on strong collaboration amongst relevant stakeholders. The second paper, Dam Safety Portfolio Screening, Introduction to Reason Tools for Nigeria, was presented by Engineer Dr. Marvin Paul Awoko, where he exposed participants to the Reason tool used for screening of dams in Nigeria. The third paper, Code of Practice for Dams and Reservoir Operations, was presented by Dr. Marvin Eduve. The presenter elucidated 13 thematic areas of focus of the Code of Practice for Dams and Reservoir Operations, which included, amongst others, the need for the Code of Practice, responsibilities of dam reservoir owners, decommissioning. He encouraged enforcement of the code by relevant agency or regulating agencies, adding that it will bring about sanity in dams and reservoir operations in Nigeria. The session ended with a robust question and answer session in which key issues were addressed. Thank you very much.
Thank you very much, Engineer Akpatim, for the recap of the one. Without wasting time, we'll go for today's program. Today we'll be handling dam failure and flooding incidents in Nigeria. And we'll call on the resource person, who is no other person than our retired Director of Irrigation and Drainage, a dam expert, Engineer Matthew Okeofie, as he delivers the next presentation for us. Please, a hand of applause.
Who is making the projections? Are we ready? Okay, this one. Okay, thank you. Okay. I don't worry. Okay.
There's a technical error for some minutes. Apologies, please.
Good morning, ladies and gentlemen. This morning we'll be discussing dam failure and flooding in Nigeria, and then we'll look at the causes, impact, and mitigation strategies. I deliberately added this so that, since it's a workshop, so that we can talk more on the causes, impact, and mitigation strategies. So, introduction, we'll be looking at, when we talk about flooding, we look at the origin of flooding, which is rainfall. We look at the highlands and topography, we look at geology, and we look at hydrological basins in Nigeria. Because stream flow or flow and flooding are determined by these things I just mentioned: rainfall, all the things that go around rainfall, topography and the highlands, geology, and then we look at the hydrological basins. Also, we look at the importance of dams in Nigeria. Of course, we know that dams are for development. Then we look at the purpose and scope of the paper, which recent events spotlighted growing concerns over failures and frequent flooding in Nigeria. We are aware of all the efforts that have been made in the past to address the issue of flooding in Nigeria. So this is the rainfall pattern in Nigeria. Most of us are familiar with this. And the origin of the flood comes from rainfall. If we look at the hydrological cycle, it comes from the atmosphere. And this pattern we see are not arbitrary. They are controlled by certain things, looking at the trade winds, the highlands, and so on and so forth. And this pattern determines the drainage basins in Nigeria. When we zoom in further, this is a 3D, this tries to mimic a 3D map of Nigeria. You see, the blue areas are the areas that are prone to flooding. Of course, the high areas where the rains originate, you don't have flooding there. And then the areas that are green are on another flat area. That is, if you go towards the Chad Basin, those areas are also prone to flooding. They are quite high compared to the blue areas, but because they are relatively flat, they are prone to flooding. Flooding is controlled by certain hydraulic factors that control flow. When you look at the basic definition of flow, they are controlled by the basic Manning's relationship, which every water resource person knows about. You talk about the resistance to flow and the slope. So when you have a flat area, it's prone to flooding. That's why the Niger Delta, which is defined as the coastal sand plains, they are all prone to flooding. The Niger Basin, the Benue Basin, all those floodplains are prone to flooding. Then the Chad Basin, the Chad Formation. If you know the divide of the basement complex, which is from the highlands you see here in the middle of Nigeria, going towards the Chad Basin, you have the basement complex. Once you go towards that plain, it becomes the Chad Formation, which is sedimentary and is flat. That's why every year people from Jigawa are always complaining of flooding. Even though the rainfall there is not much, but they complain of flooding. Maiduguri, which receives usually the least rainfall, they complain of flooding because of the hydraulic factors there. So it's important for us to also look at this factor. Now, these are the hydrological basins. These are natural hydrological basins. They are not political. All of us are very aware of this. Of course, these hydrological divides were created were determined by the topography of Nigeria. You know, we have 8 of them. And ironically, the areas that produce the most rainfall, which is hydrological area 7, the East Littoral, they are not as flood prone as the areas that produce the least rainfall. We're looking at the Cross River, Ebonyi, the catchment basin, and then the Imo Littoral, that is the Eastern Littoral Zone. They don't attract so much flood. And yet, if you look at the yield of the catchment in terms of water, they carry a lot of water. But most of them are contained within the channel. But if you go up north, the hydrological area 8, which is the Chad Basin, which has the least in terms of rainfall, is one of the areas that are prone to flooding. So it's a complex relationship. It's rainfall, topography, and as I said, the hydraulic factors. Now, we know the history of dam. Most of you are very familiar with it. I don't need to dwell so much on it. When it started, the kind of dams we have in Nigeria, and so on and so forth. But the only thing is that in the 80s, there was this policy that we should emphasize on building earth dams in Nigeria. That period marked the development of the techniques and increasing the knowledge base in design and construction of earth dams. I was a very young engineer then, but I know that Ogun-Osun River Basin topped the list. They had a lot of experienced expatriate engineers who taught the people there how to design and build earth dams. That was the time they started building dams, building spillways with culverts, because it was what was possible for them. If you look at some of the dams in Ogun-Osun, I don't know how many of you who are familiar with that area, Shekpeteri area, Shekpeteri 1, 2, and all those areas. I think those spillways were built with culverts because they couldn't construct Ogi Spillway. But they did the hydraulic calculations and they were able to build something that was suitable for them. Ogun-Osun River Basin developed even the code of practice for the design of earth dams. I was a very young engineer then. So I had already explained this thing about what topography does in terms of defining flood-plain areas. So we are looking at, these are the overview of major rivers and flood-prone areas. We look at the Niger system. The Goronyo, Sokoto-Goronyo Zamfara system is another area that is prone to flooding. As I said earlier on, it is also the topography. There's an area between Birnin-Kebbi and this town, what's the name of this popular place we go to do fishing? Everybody knows that area as a Zaurapoda. Sorry? Arugungu. Zaurapoda. It's a extensive floodplain. If you go beyond that, further down, floodplain. And yet, the amount of rainfall there is not much, but it is also determined the flooding there is extensive. Gorara is not as prone because of the kind of geology of Gorara area. The areas are well defined. It's not too much flood. Kaduna is not, is towards the junction with River Niger that it becomes flood prone. Upstream of Kaduna, the river channels are defined. And so also if you go to the Benue system is also one of the major contributors to the flooding in Nigeria. As a matter of fact, during the flooding season, my own calculation is that Benue contributes more than 80% of what goes on in the Niger. I will show you some hydrographs to buttress my point, because Benue is largely unregulated. And Benue collects water from two highlands. From the topography maps I show you, most of the rivers contributing to Benue come from either Jos Plateau, Jos Highland, or the Mambila Highlands. And of course, you know the process of rainmaking, that any highland obstructs the movement of the maritime air mass. And once it hits the highland, you have a lot of precipitation. So all those rivers, as I told you, Gongola, Hawal comes from the Biu Highland in the northeast, even though it is so far away up north. Because of the Biu Highland, Hawal carries a lot of water. Gongola comes from Jos Plateau. You now have Donga, Taraba, Katsina. Those ones come from Mambila area. They all carry a lot of water. Deb Mada system comes from Jos. Those areas, those rivers collect a lot of water from rainfall, and they all get into the Benue. Then you have the Chad Basin. You have the West Littoral. The West Littoral, the major one that is flood prone is the Ogun River, where you have our two dams, the Ikere Gorge Dam and then the Oyan Dam. Again, because of the low-lying area of this coastal sand plain from Abeokuta to Lagos, those areas are also prone to flooding. You have the East Littoral. The Ebonyi system is one that is causing problem in that East Littoral. The Cross River doesn't cause much problem, but the Ebonyi system, because of the clay formations, the entire Ebonyi River is on clay. That is why, take for instance, if you look at our Ivo Dam, when we designed the Ivo Dam, and we'll discuss it later, we checked the spillway capacity. We came to about 200 meters, because all the water that comes as rainfall transformed into runoff is clay. We look at the Niger Delta. Those areas are perpetually inundated. They have 2 seasons of flooding there. The floodings that come during the rainy season, which is caused by the immediate runoff. Then later in the year, the runoffs coming from upland catchments will also cause flooding in the Niger Delta. So, having given you the general overview of flooding, we're looking at dam failure. We're looking at dam failure and flooding. Dams fail hydrologically, geotechnically, or structurally. Then operational failures also occur when you do not manage their operations well. That is what leads to panic releases. But if you don't do it, some dams will fail. Natural causes. Of course, when you have unprecedented rainfall, when you design your spillway, you say you want to design your spillway for the most probable flood. Sometimes you say, okay, I want to design my spillway for a risk of 1 in 10,000 years. These things are statistical, particularly in situations where you don't have even up to 20-year data. To me, I call it an intelligent guesswork. But as a hydrologist, I accept all the rigorous brain work we do there, because you don't have any other thing to do. So we look at the flood events in subsequent slides. We're also going to look at the piping, which is geotechnical, landslide, earthquake, and foundation failures. We also have equipment failures where you are not able to operate your gates. A good example is Kainji Dam. Kainji Dam was impounded in 1968. From 1968 till 1988, nobody did maintenance on Kainji Dam. And ironically, Nigeria is a God-blessed country. The dam never spilled for those 20 years. Incidentally, it was only when they were able to do maintenance on the gates, because Kainji has gated spillways and all the rest of them. It was only when they were able to do maintenance on the gates that they were able to operate the gates. If we had had any serious flooding before that time, Kainji would have been in trouble. It was that same 1988 that we had the failure of Bagada Lake Dam. The storm was everywhere. And we were in council meeting in Kano that year, and everybody was talking about Kainji being repaired. And before we got to Abuja, we got the news that Bagada Lake had failed. And also we got the news that Kainji was able to operate the reservoir that year. So if Kainji was not operated that year, Kainji would have had a problem. We have structural failures, we have upstream dam failures. I don't think we've had anything like that in Nigeria. But when we do our dam break analysis, for instance, if Kainji fails, of course, Jebba will fail. And you know what? If Jebba fails, Shiroro will fail too. You know why Shiroro will fail? Because the entire water will be put on the Niger Valley, and no water will come from Kaduna anymore, and it will back up. The backup will go as far as, now I think we'll have Zungeru even before Shiroro. That could block Shiroro from failing, but for sure, Zungeru will go. That is what the dam break analysis that was done by SMEC in 2016 said. The backup, which is if you have a very high water level on the river channel, the tributaries will not be able to discharge anymore. They begin to back up. That is even part of the causes of flooding in so many areas in Nigeria. When you have so much water in, say River Niger, for instance, the tributaries are not able to discharge. All the adjoining communities on the tributary will be flooded immediately. So we've had such problems. We now have, if you have rapid drawdown of water from a dam, it can also cause some geotechnical problems. Sabotage. I remember during the peak of insecurity in Nigeria, we had to put in monitoring things to be able to safeguard our dams. Then you can have planned removal. When you plan your removal, you can evacuate what you have in the dam. So this is from conferences like this that, one was in Costa, that 35% of the dams of dam failure were caused by overtopping. We know the cause of overtopping. When you are unable to size your spillway properly, then the water level will go above the dam crest and then begin to overtop. It will cause flooding. We have 30% due to foundation defects, another 28% from piping and seepage, and only 8% from other modes of failure. Now, this is just the procedure of dam failure. In the situation where, as I said earlier on, where we are not able to have a correct sizing of the spillway, and you are not operating your reservoir, because if you are operating your reservoir, for instance, as I will show you later, even when your spillway is not adequate to take the flood coming in, you can create space for the excess water. That's why you have a reservoir, so that you will not put your spillway under pressure. The first thing that happens is that if the reservoir is unable to absorb the inflow, The outflow from the dam then it seats the spillway capacity and then begins to build up and then topples it, the dam. That is a major that is a major hydraulic failure. Sizing the spillways, designed to accommodate most probable flows or flows of a given return period. You see, hydrologists over the world, some people say most probable flood, which sounds better secured when you say the most probable floods. Then some of us, like me, I try to quantify the risk I'm taking. So I say I want to design for a specific return period. And you will know return periods has a risk. If I'm saying 10,000 return period, I'm looking at 1 over 10,000 probability of exceedance. That is the implication. So it depends on how you as a hydrologist want to address it. Now, the complications there is this. You have data, 20 years data, 30 years data at most. And you want to design for a flood that occurs 1 in 10,000 years. That means that the data you are going to simulate will be like 1 million, 2 million. Because 10,000 is 10,000 on the average that event will happen. That means you're going to have several times that 10,000 data. And how do you do it? You begin to see how the short data you have fits into a distribution function. A distribution function, mathematically described as a function that describes how that data is extended for 10 million years, for instance. You see the task hydrologists go through. So it's something that when you do it, you can't even go to bed with 2 eyes closed, because you have 20, 30, 50 in Nigeria, for instance. And then you are designing a dam that has a spillway capacity that can accommodate a flood of even 1,000 years. Let me give you an example. Alau Dam was designed for 100 years originally. It was breached, I think, 1994 or thereabout. Now, it was obvious that 100 years didn't make sense. But 100 years to a non-hydrologist say, oh, this flood can occur once in 100 years. Let's leave it. But let me tell you, the 100 years is 100 years on the average. That 100 years can occur tomorrow. That magnitude can occur tomorrow. So we raised it to, I think, 1,000 years when they renovated Alau Dam. The recent failure didn't come from the spillway. It's a different thing altogether. But it is still a guesswork, because which data did you use for it? Which data did you use? The data that is why I keep saying that in Nigeria, we must lay emphasis to data collection. I was in hydrology, and I'm still in hydrology. I associate with them. Nobody is serious with data collection. People are more interested in building dams, irrigation, and all the rest of them, but nobody's talking about data collection. So the issue of this is a challenge for flooding, because when you are unable to size their spillway properly, you are at risk. Of course, once you determine the design flow, the other hydraulic calculations are straightforward. They're just mathematical expressions. So, as I said, the hydrologist must be witty, must have experience, must be hands-on to be able to know how to progress on this. As I said, most sites, when you want to build a dam, most of the dams we are building, we just decide, okay, we want to build a dam at Gorara. When we were going to do Gorara, it was when they were doing investigation that they established the hydrological stations. I established a hydrological station in Gorara in 1991. because I was in hydrology then. The first solid state logger that was established was in Gorara, in Jere, along Kaduna Road, because that was where that was accessible. But you'll be sure that the value we are getting there is different from where the dam was built. The original dam proposed for the Gorara transfer was to be around Jere. That was done in the 80s. So for me, because I have engineering background and I was in hydrology, they asked me, where do you want to put the solid state logger? I said, let's put it in Jere, 1991. So we sited it there. When they now started doing the investigation for the dam, they saw that a better site was upstream. They had no data. So that's the first challenge you have. You don't have data. Even meteorological data will be scanty. You look at the nearest meteorological station and you pick. So you deploy various techniques as a hydrologist to be able to see how you can come about getting your design flow. It's just one figure. It's just one figure. So this is what I propose. This is what I do. You know, when we are the short time we had design units in dams and irrigation, I read so many reports. All the consultants were approaching it the way they wanted. And we were accepting that, because what do you do? I also remember that in one of the subcommittees of NICOD that time, I proposed for us to do what they call flood index, so that zones will be categorized. It will be easy for consultants to use the flood index for this estimation. Femi Shonuga was the chair of that subcommittee. That was 2006 or thereabout. But, you know, because of finances and lack of passion too amongst the members, that committee never saw the light of day. But I did it out of desire, because I knew that we needed to have a basis to estimate our design flows. So this is what we do, or this is what I think I recommend based on my experiences. We do data gathering, catchment data. These days is even easier because you have digital data. In those days, you have to go to survey to go and get your maps. But today, you can focus on an area, delineate the catchment area accurately, use digital elevation maps to know the slope of the area, collect the soil type, collect the land use, get this average slope. You see, these things are things that define the way the flow goes on a catchment area. And it is these things that determine the shape of the hydrograph. Now, you look for rainfall data, because that is what is mostly available. These days, we have what we call satellite rainfall data. You don't necessarily need to have rainfall station around that area. You can get area rainfall for the entire catchment area, which is more accurate. These things, I encountered these things when I had left the service. You can get your satellite rainfall, and then look for a station, a meteorology station close by, and then check the relationship and see how you can use this area rainfall. It's a better estimate of how much rain you have on the catchment area. Now, when you have all these things, you do your rainfall runoff modeling. The modeling of the rainfall runoff modeling is to transform the rainfall you have into runoff. This transformation is what people call rainfall runoff modeling. But you see, I do it manually. I do it manually. And what do I do? When I have the soil type, the land use, and topography, there's this guideline prepared by US Bureau of Reclamation. You know, I attended those courses over the years. I tried to get all their manuals. The US Soil Conservation Agency, they developed relationships between different hydrologic soil groupings. You see, the transformation of rainfall to runoff is dependent on the soil type, is dependent on the slope, on the vegetation. These are raw ways of estimating your runoff. And the hydrologists in those areas, they use these figures to develop what we call curve numbers. Curve numbers. If you go to your design of small head dams, there are graphs show you different curve numbers corresponding to different hydrologic soil groups. So these things will guide you in transforming the rainfall you have over runoff. But before this transformation, this rainfall you have, you must do what we call frequency analysis on it. What do I call frequency analysis? You are looking at rainfall that occurs rarely. You are looking at rainfall that occurs maybe 1 in 10,000 years that will cause this flooding you are talking about. So you must subject the data you have to frequency analysis. So details of this, I have a second slide that I have a spreadsheet that shows the procedures I've been using over the years to do these designs. And I've done more than 40 spillway designs over the years. Some of them came out successful. One of the scariest one I did was the one I did 5 years ago in Edo State. Luckily, I identified the fault because I was involved in the construction of the dam in Edo State. So when we were doing the construction, the first rain that came, I saw the flow. Because I have experience, if I see a flow, I can estimate the value of that discharge. I told my people that no, my calculation is wrong. So when I did the design, I didn't have access to digital maps. So I went back again and discovered that the catchment area I used was very, very small. In fact, there was even a dam upstream, which I didn't even see. So by the time I adjusted the catchment area, I got a very good design. So that reassures me that at least what I'm doing or what I've been doing is correct to a large extent. So, Madam, I did the spillway calculations for So, Madam. The spillway engineer Castell, when he was alive, he approached me in 2005. I should do the design. I did it for him. The first rain, he was scared because he himself was very worried. But thank God, up till now, the spillway is serving. Even with the 2012, 2022 floods, the spillway is there. And it's not as if it was oversized. Because if you go there, you see it spilling fully. The one in Soma is an Ogi spillway built by late engineer Castell. So what I'm saying is that everybody, if you are a hydrologist or a practicing water engineer, you can look at these details, for what people are doing and develop your own method of doing your design flow. It is very important because if you get it wrong, the dam will go. If you get it wrong, the dam will go. So by the time you finish the rainfall runoff modeling, you now route the hydrograph you have obtained through the reservoir to get their design flow. These procedures I'll show if we have time on a spreadsheet I have. So these are different categorizations of flood. Imminent flood, minor flood, moderate flood, major flood, and destructive floods. So routing, I just talked about routing. Many people say that when you build a dam, that you create problem. The first hydrograph, the hydrograph you are seeing on top, the blue line shows if you don't have a dam at all. The second one shows if you have a dam, you are not even operating the dam. The dam is just standing, like most of our dams. The presence of the reservoir attenuates the peak, as you see. This attenuation is dependent on the capacity of the reservoir, the shape of the reservoir. Capacity and the shape. If it is long, the shape of this hydrograph is different. Now, you can see the two hydrographs. The first one is natural flood. The second one is modified by dam. The other one is the one if you operate your reservoir. You can see the difference. If you look at the areas under the curves are the same thing, obeying the laws of conservation of mass. But you have a better result downstream. Now let's briefly talk about geotechnical failures. Piping. When water percolates through soil under any hydraulic structure, it may happen to exit vertically upwards at a downstream. If this water moves with a high hydraulic gradient, the seepage force or the drag exerted by it on soil particle may push them up, and soil particles at the exit point of the water may be removed by the force of water. This had to do about hydraulic gradients and all the rest of it. That's why when you are doing your design of the dam, you take care of all these problems. We talk about cut-off walls. This just goes to explain why we do certain things when we are doing our dams. The cut-off wall elongates the flow because once you have water behind an earth embankment, there must be flow lines. So you begin to put in things that will reduce the hydraulic potential of the flow lines on the other side of the dam. So by the time you introduce features like cutoff, as we see much later, okay, this shows exactly what I'm talking about. You can see the flow lines going under the dam, and those ones coming down are the hydraulic potentials. So there's a way the flow will go, and it will exceed the critical potential. It will begin to remove soils, and once it begins to remove soil, it creates a pipe under the dam. These are different kinds of piping. You have heave piping. Of course, as I said, if you want to reduce this, you begin to introduce features. You can see the introduction of something under. You increase the flow part. So by the time the thing is coming out, it's already very weak. So it will not be able to carry soil along the line. You can also, because you also have flows going through the dam. You have structural failures for concrete dams, and you have combined failures. So these are some of the case studies that I can remember. I talked about Bagauda Lake. Bagauda Lake was purely a hydrologic failure in 1988. There was a heavy rainfall, and the spillway couldn't take it, and it went away. You have Cham Dam. Goronyo wasn't a failure. Goronyo was the emergency spillway just came to use. What do I mean by that? They had done the regular spillway for Goronyo, and then they provided an emergency spillway, which takes care of excessive flood above the design flow. Usually the invert level of the emergency spillway is higher than the invert level of the regular spillway. So when the flow above the spillway was exceeded, it went to the emergency spillway. Emergency spillway, they don't bother with making sure that it's not a permanent structure. Once it works, it gets washed away. And that was what happened in Goronyo. It wasn't a failure. But I mention it here just to differentiate between having your design flow and take, for instance, what we would have done in Ivo Dam, because there was a controversy on Ivo Dam. When we did the design of Ivo Dam, we had a very long spillway. The contractor refused to build it. He said it was too long. He couldn't comprehend that length of spillway. But our calculations showed us that. So I wanted to engage him. I told him, okay, come and tell me why he arbitrarily reduced it by 50%, the contractor. So I told him, come, let us discuss why you reduced it. As a contractor, if you have your in-house design team, you can redesign the scheme, the project. But you come and tell your client how you arrive at your figures. Of course, I knew he didn't do anything. He just couldn't figure out why a spillway would be that long. But, based on these things I told you here, factors you must put into consideration when you are transforming your rainfall to runoff and all those things, that was what we got. So he refused to come and he didn't have anything, but he just said that he wasn't going to build it. So he went ahead and built what he felt he was going to do. Now, what I thought we would have done was to provide an emergency spillway for Ivo. But you see, at that time, I couldn't enforce my views. So he went ahead and built. I don't know whether the dam is working now or not. Sorry? You see? I'm just hearing it now. Because it was wrong. I designed that spillway. It was wrong. So let us be, professionals. We should adhere strictly to our ethics. This thing happened over 10 years ago. Alau Dam. Yes, Alau Dam didn't fail because of, it failed partly, the much I know. I've not seen the details, but the much I know about Alau Dam. And Alau Dam came because so much water came into the dam and put pressure on the fragile infrastructure, and it gave way. Now, I was reading a recent report about interbasin water transfer from Hawo. The director of dams gave it to me. And one striking feature there was control of water that goes into Alau Dam. I pray that that report will be executed. I know there was a control works that was done by Dr. Gowon years back on Zanzibar, on Zambiza forest, to get water from the Zambiza wetlands into Ngada, because Ngada was receiving very little water to feed the lake, the Alau River lake. So those control works were done to augment the flow into Alau Dam. But then, I don't know whether the control works that time had provision to regulate how much water that will go into Ngada River. Because further downstream, you have the Jerebo and the South Chad irrigation scheme, and also even the Lake Chad that are so thirsty for water. The primary purpose of the interbasin water transfer, the report I read recently, was to take water from Hawo River, which goes to River Benue eventually, to the dry areas. But it can be a problem if the control works, this same control works I'm talking about, is not in place. Because the same river, the same transfer will go into Zambiza and then get into that bifurcation. So there must be a control to say, no, you have to continue to Jerebo and South Chad irrigation scheme. So this is a different thing altogether. But the issue is this, that flooding occurred in Alau, and if the control structures, the hydraulic structures, and then all the mechanisms are working, maybe we will not have flooding, The 2022 to 24 flood events, no, this is 2020, 2012 and 2022 flood events. These are some of the vehicles. There was an error there. I should have been referring to 2022 and 2012 flood events. So these are some of the figures of the effects of those flooding events. Now, we talk about the Lagdo Dam and its impact in Nigerian communities. I will say something different about Lagdo Dam, and I want to make it clear. Lagdo Dam is not the cause of flooding in Nigeria. I'll say it because I'm a hydrologist. I'll say it because of the facts I have. Lagdo Dam is not the cause of flooding in Nigeria. What comes into Nigeria from Cameroon is just 10% of the flow in Lokoja. And that 10% does not even go anywhere near Newman. In 2016, there was a dam break study done by SMEC. Dam break study is done to simulate what will happen if a dam collapses. The simulation indicated that if the entire 7.7 billion cubic meters of water in Lagdo is thrown into the Benue Valley, by the time you route this flow through the extensive floodplains of Benue, by the time you get to Newman, you have almost no effect again. Newman is still in Adamawa State. Between Garwa and Yola Town and beyond, you have extensive floodplains, and the water will spread to these extensive floodplains. That is why the new Dasenhausa Dam is so good for irrigation, because the entire area is flat downstream of the dam. This is an advantage in terms of attenuation of flood coming from Cameroon. If you go to reports, I don't know whether you have it, I have it in my house, reports of studies done by Water and Dams in the 80s for Upper Benue. They did extensive studies. I am seeing Engineer Musa here. I don't know whether you are working with Water and Dams. Did you work with Water and Dams? No. They have these reports. Read those reports. Extensive floodplains. That is what is of good use if we do that's a Hausa. I'm in support of that's a Hausa, because it will give you enormous irrigation potentials. Those areas are good. And those areas are what is absorbing the flooding from Lagdo Dam. Each time I say this, people will say no. Even if you go to the internet and Google, every information you have is that Nigeria had an agreement with Cameroon to build Lagdo Dam, to build Dasenhausa, to prevent the releases from Lagdo Dam. But nobody can show you that agreement. Nobody can show you. I came to ministry in 1983. And when I came, I started from the design unit with Dr. Dewumi. So, on that note, even if you have problem with releases from Lagdo Dam, we have protocols, international protocols. In 1984, I'll be talking about it later, we developed what we call the Hydro Niger Project. That was when Cameroon became a member of NBA after the construction of Lagdo Dam. This is part of the integrated water resources management plan for the entire Niger and Benue river system. 65 data collection platforms were installed. They were telemetric. I was supposed to go on a short training on modeling in 1984 to teach us how to do hydrologic modeling. But I got admission the same year to go and do my master's degree. Engineers were trained in the ministry here of water resources on this modeling. I remember Engineer Deleke. He was trained. The Hydro Niger project was supposed to coordinate the operation of all the hydraulic structures within the Niger Basin, Lagdo Dam inclusive. These are riparian rights. Nigeria has the riparian right to insist on these agreements that you cannot arbitrarily operate your dam. We have the right. And if Lagdo Dam is operated, as I will be talking about reservoir operations here, properly, you don't have a problem. Yes, Lagdo can affect some communities, at the boundary, going towards Yola. But it has nothing to do with the flooding in Lokoja or even in Makurdi. But we can address it. It's definitely, it will be affecting some communities in Nigeria. But we can address the issue from this bilateral, for multinational relationship we have. So this is what I'm talking about. If you look at the hydrograph for 2012, the flow in Makurdi, the blue line shows you the hydrograph of the flow in Makurdi in 2012. You see, as hydrologists, we speak with figures. That same year, the maximum flow at the border town with Cameroon was 3,000 cumecs. 3,000 cumecs, that's the maximum flow. But in Makurdi, we recorded almost 18,000 cumecs, 6 times that flow. So what that tells you that 3,000 is just about 1/6 of the flow of Benue in Makurdi. And from our knowledge of hydrology, if you had 3,000 coming into Nigeria, a good part of it will dissipate within the floodplains. This is the same year. The red one now represents the 2012 in Lokoja. We had about 32,000 cumecs in Lokoja. And as I said, at the border town, we had 3,000 cumecs. So this is about 1/10. And it also tells you, you see, in Makurdi, before you have rivers like Shemanka, Mada, and other ones flowing into Benue, you already had 18,000 cumecs from Benue coming in. And in Lokoja, you had 32. That means that Benue contributes much more than Niger at the confluence. So with the impacts on dam failure and flooding, we look at the humanitarian angle, the economic angle, environmental angle, and social angle. And the roles agencies play. NEMA, they are doing their best, but they can still do better by being proactive. The investment in NEMA can be shared between agencies that are supposed to prevent this flooding. A lot of resources are devoted to what has happened already. But proactively, you can stop some of these things by even spending less. We don't have early warning system. We have, but we're not using them. They're not activated. I talked about the Hydro Niger project. The Hydro Niger project had a national forecasting center in Kaduna. Many of you may not be aware, but we had people trained. Of course, there's nobody who is still in service who was part of it. But Oyeniyi, most of you know Oyeniyi. He was the head of the team. They were supposed to be forecasting and coordinating the forecast from the International Forecasting Center in Niamey. They would do the national forecast, and then Niamey would do the international forecast, including Lagdo. So we had an early warning system 40 years ago. 40 years ago. We had a telemetric station 40 years ago when we didn't even have GSM. We were using satellite-based system to transmit the data in real time. People were taught how to maintain these data collection platforms. I did one of my trainings in Baro, in Niger State, on how to maintain data collection platform in 1989. We gathered in Baro. We had the experts. They took us to Baro, and they dismantle the entire data collection platform and put them together. You collect the water level, collect rainfall, collect all the meteorological data in real time to feed into the tools, which is the hydrologic models. We had them 40 years ago. So when I say we don't lack of early warning system, yes, but we had the infrastructure. It's just to activate them. And now it's even easier. The solid state loggers, which we were using in those days before GSM came in, the recent ones, you can put in a SIM card in it and it will be relaying data to you. You program it, put small battery. Maybe every 6 hours, it will send message to you. You stay in Abuja, you know the water level, all the areas around the country where you have your instruments. And then you can take your decisions. That is the way it's done everywhere. Well, in what you read, you are planning to have dam safety regulations and enforcement. The much I know that we didn't have it before I left dams. But we have a comprehensive one for Jebba and Kainji. I've even shared it with some of the people in dams. Very comprehensive. Developed specifically for Jebba and Kainji by Mainstream. So it will be a working document for you people to look at it. I have the document, I can still share it with you people, but I've shared it already with people in dams. Sorry? Well, Mainstream were the people that, what happened was that before the unbundling of PHCN, PHCN gave out the jobs to SMEC. So by the time the job was being concluded, Mainstream had taken over Kainji and Jebba. So they were the people that received the report. They are people that invited us. I went as one of the people from from dams then to look at the document. And that was 2016. So, well, the important thing is that there's a document that is useful, and then Kainji and Jebba is an embodiment of everything. So it's to adapt it and see how you can use it for, it will be a good working document anyway for if you want to set up this. I saw when they were talking here, when you are doing a recap of what we did yesterday, that you have plans to do that. So it will be a good working document for you people. Then poor urban planning, this has been said everywhere, We don't do design of our drains. And even when you do it, people violate it, people block the drains, people do anything they like, But you see, I want to stress something, In where I live, in Lokogoma, there was no flooding before people came there to live. People have settled there, there's flooding. It's a simple reason, it's because the runoff is being generated more than what was happening before because of the development in the area. So there's need to do that. If you look at the areas that are planned well, like Wuse, for instance, Maitama, you hardly talk about flooding there. I lived in Wuse for 23 years. My house was just very close to a river. There was no, we didn't even know about flooding because it was properly planned. But in Lokogoma, once it rains, some people cannot go to their houses because it's not planned. And this planning is just for government to be proactive and do what they should do. So these are all mitigation and adaptation strategies: strengthening dam inspection, multilateral agreements I've spoken about NBA, investment in flood forecasting and early warning systems. We cannot go out of it. We must invest in it. If we are trying to solve this problem of flooding, you must invest in it. You must do real-time data collection. You must be able to predict. You see, the issue is that things are becoming even easier. Why am I saying this? By as early as February, information is already available how the rainfall will be in Nigeria. It wasn't like this 40 years ago. 40 years ago, you can only predict 4 days ahead of time what will happen. But now, as early as February, Met Department can predict the pattern of rainfall in Nigeria. They can tell you that these areas, and based on this information, NISA will now go ahead and do their flood outlook and go down to even communities. The Mokwa flooding was predicted by NISA. So development has gone beyond that. We just need to just add a few things and it begins to work. We need to have these decision support tools, rainfall runoff models, reservoir operation tools, and river routing models. These things are free. I can stand here and tell you softwares that are free that do this in data. The Hydrologic Engineering Center softwares, they are free. It's just to download them and study them. At my age, I keep updating myself on the use of these softwares. If at almost 70, I can sit down and read these things, young people who are in their 30s should be able to do it. I started using this software when I was under 40. I went to Davis for training in 1995, and I acquired these softwares. I came back, I made a presentation, and that was what I used in an. Hello? So we keep, these things are available. The young ones, I'm advising them that they can develop on their own. You don't need to go on a training. These days, you can even stay in the comfort of your house, download these softwares, download the tutorials on YouTube, and you watch it and you begin to develop yourself. You have the rainfall runoff ones, you have the reservoir operation ones, you have the river routing ones. Even if you understand the concept, I use Excel to do all these calculations. I use Excel. As a young man, I was programming in Fortran. Later, I started using MATLAB. But these days, I use a spreadsheet. It's simple. So I've mentioned some of them. You have the HEC HMS, which transforms rainfall into runoff. It has a deterministic component. You have the stochastic simulations. These things are just for you to know, but the packages does these things for you easily. But you need to know what you are doing. We look at reservoir operations. The reservoir operations is what I want to address in more detail, because people take it for granted too much. They tell you, we've told the river basins to start releasing water. You don't release arbitrarily. I don't understand, because there's nowhere you build a dam to do irrigation, to do hydropower, to do water supply, and to control flooding. And then you arbitrarily just tell somebody, okay, start releasing. We have to tell them, start releasing. No. Each reservoir has a specific rule based on facts on ground. As I will be showing you later, I will show you a curve. Good. You see, if you have a dam like this, these lines I put in here are not fixed. They are just to describe what I want to do. You see, you can allocate the red zone as your flood storage. The conservation storage is the blue zone. The conservation is to meet all your requirements. Requirements includes for irrigation, for water supply, for hydropower generation, because you need water to do it. Then you have buffer. Buffer storage is when you have very serious drought, you can go into your buffer. You have your debt storage. In reservoir operations, your objective will be to be on the line between the red line and the blue line. If you have information ahead of time, that is what I was trying to say in the other slide. The information has to be ahead of time. Like in February, you have information that you are going to have a very rainy year. What you do is to create space, the red space. So that line will go down accordingly, according to your dynamic programming. To be able to accommodate that, you must quantify the amount of floods you are expecting, which you want to store. Because if you don't create this space, you are going to put pressure on the riparian communities. You are going to release too much water at a time. That is why you have a dam. Now, if you have predictions of dry weather, you don't need to have the red storage. That line will not go up. So you only have the blue all through, because you need to store enough water to meet your requirements. To be able to do this, you cannot do it arbitrarily. You cannot do it arbitrarily. You must use information that this is what is going to happen. If I do this, what will be the implication in the next month, in 2 months' time, in terms of doing all the things I want to do. That is why we call it dynamic programming. Time. So, these aspects, that is why each time they talk about, oh, let us just tell them to start releasing. They didn't start releasing on time. Release what? Now, when you release your water from the dams, you must also know what happens downstream. That's when we come into routing. Routing tells you, if you release this quantity of water, what impact will they have on the riparian communities? The same SMEC, when they did their own, they were able to put in benchmarks, beacons on the Niger Valley, that this is the areas that are likely to be inundated if you have this quantity of water coming from Jebba. Of course, when you do these things, you now have what we call inundation maps. By the time you have done all the things I've talked about here, what you're going to deliver will be inundation map. We need to have community-based disaster preparedness, climate resilient infrastructure and land use planning. Now, these recommendations came from what we did in 2022, the National Strategic Plan. There's a compelling need to have it. It's unfortunate that that report, I don't know whether it has been implemented, whether they are thinking of implementing. Some members are here. Engineer Dala was part of the committee. So these are the recommendations that came out of our committee to have a national strategic plan for flood management. You can see all the things I've been talking about are all listed here. But the next diagram will be much clearer. You see, in one, it's telling you data acquisition and integrated flood management. 2, coordinated multi-sectoral flood early warning system, and so on and so forth. So these strategies are to address the issue of flooding. It's inevitable. I don't know whether people have read the report. People who are to take decision have read this report, because I don't know which other report that will be better than this report. It's comprehensive. Setting up of the National Flood Council, although these are things that are inevitable. And when you have it in place, these strategies must be put in place. Conclusion. I like this quote, that every flood is a policy failure in disguise. I think it's correct. From what I've said here, every flood is a policy failure in disguise. If we address our policy issues to a large extent, Netherlands is surviving because they have firm policies that addresses issues of flooding. A good part of Netherlands is below sea level. But they are containing it. When I was graduating from Belgium, they opened up one of the 8 wonders of the world, the Delta Works. It was commissioned as a student, we visited it when they were doing the construction to control flooding. Because Netherlands is at the estuary of so many big rivers in Europe, the Rhine, the Scheldt, all of them enter the North Sea from Netherlands. So they have serious flooding problems. But you don't hear about flooding in Netherlands because they have, measures to contain it. So, why I'm saying this is that the issue of the water bills, the politicization of water bills, incidentally, the person that brought this issue of water bill politics is now on the other side of the politics. Late Udema Akpan, my very good friend, was a good friend to Akpabio. So when Akpabio started talking about the water bill, I and Udeme scheduled to go and see him, to explain to him to pipe down. Because it's out of ignorance. Even people from my area, when I went to Igbo State and Anambra, the flooding in Imo State, in Uguta, Ebema, the flooding in Anambra area, the entire Anambra West local government is permanently inundated every year. It's not the river from Anambra State. It's not the river from Anambra State. What is causing it is that when River Niger level goes up, Anambra begins to flow backwards. Anambra River begins to flow backwards. It no longer discharges into River Niger. And all the water will begin to inundate all the low-lying areas in Anambra West. Their school years have changed. Like during the rainy season, they move out of the schools. So without integrated water resources management, how do you address the problem? And you are fighting the water bill. It's lack of understanding. So because of politics, we're not able, because if you don't pass this bill, you cannot talk about integrated water resources management. And that integrated water management is what we're talking about here, to address the issues of flooding. It's not something you address from only your own area, your own state. You must have trans-state issues and so on and so forth. So, and then the death of multilateral relationship, I've spoken about it. The MBA is not working. Otherwise, why is Lagdo Dam issue? Release it be an issue to us. If Lagdo Dam if this MBA is working. Thank you. Sorry, am I going to answer questions? Normally, now there should be questions. Huh? Okay, so. Don't worry. I was expecting my intro leg to stop. No problem.
Please let's jam our hands again once for our presenter. It is time we take some questions and comments and okay. So please, if you have questions, comments.
Like I was saying, it's a real opportunity to see Engineer Kofi around, and then you allow him to go because he has so much to tell us. Some of us here are born mostly online. We have benefited so much. Thank you so much. I am not competent to comment on quality of what we are giving us. What we are saying is we can say so much the time we see you around. It's not like a question per se. In the causes of dam failure and all that, yes, so many parameters we put which are understood, but I really want you to a little dwell on how rapid drawdown can cause dam failure. I know rapid drawdown, yes, downstreams and all that, but in relation to dam failure, we will need you to just tell us more. Then the second one is about this Lado dam. Yes, at many times I've discussed with you, I got the this and all that. But we sometimes when we tell the public and say, yes, about 10% of releases from Lado Dam come to Nigeria, they ask us, where does the remaining 90% go? And some of us, we just try to perambulate. So I wouldn't mind if you can just, 10% yes coming to us. The remaining 90%, how was it distributed? Does it go? And all that? Thank you, sir.
Good morning, everybody. I am Montevega Sebastian from Dams Department. Oga, thank you for the presentation. You really enlightened some of us. A lot of us can gain from your presentation. The last time you presented for us and why should we gain from it? But from your presentation, sir, I just want to ask, how do you contend with the cough when you have flash floods in the design?
Come again.
How do you contend with the flash floods in the design? Because it comes once in a while to avoid the top flash flood issue.
Okay.
Thank you, sir.
I suggest I answer some so I don't forget the questions, you know. Maybe let me answer the ones that. The last one I'll start by explaining. Otebe, the flash flood issue is exactly what we look out for when we are looking for floods that are rare. You know, when you say you are looking for floods that occur rarely, it is this kind of event that defines something that is rare. You know, if you say you're looking for a flood that occurs once in 100 years, 1,000 years, it is this kind of flash floods. Like what happened in 2012 is a rare thing. And that is why our statistics is important. The first thing you do is to collect your data. Then, I didn't want to elaborate so much on it. When you have your data, usually why I will go to collect rainfall data is that it's available. More available than discharge data. So you can collect a larger one, like 50 years. Now, if I have my daily data, which explains what kind of rainfall I've had in that area, I will use it to construct a population that describes how rainfall pattern is in that area. You can pick all these rare events, and that is what we pick to transform to runoff. That is what you pick to use in designing your spillway. So your question directly, the direct answer is that the rare events you are designing for is for this kind of flash floods. And in my explanation, I gave you the parameter. You see, floods is flash because of topography, soil type, land use, and intensity of rainfall. It's not only one factor. The same amount of rain that fell in Jos area, for instance, will not cause the same flooding as the same amount of rain that falls in Maiduguri. Because Maiduguri is flat, or Kano. So that is why in my own style of calculating these rare events, I took our time to define the catchment area. And thank God we have digital data. I can get an average slope of a catchment area digitally now, unlike 8 years ago, to be able to help me to construct my unit hydrograph. Let me not go too far. Then, your question. One question is on drawdown. When your dam is full, if you look at the flow lines, the pharetic line, you see, if you have an air dam, the pharetic surface goes from where the water level is on the side of the dam. It is highest there. Is the pharetic level is the same as the water level in the reservoir. Then if you go down towards the air side, the pharetic surface drops according to the properties of the soil. You understand? Now, if you do fast drawdown, the water level on the reservoir will go down, but the water level on the dam will take time to drain. And that is where there's a problem. It has problem with the shear strength of the soil, because if you have water in the soil, it has impact on the shear strength. The balancing effect you had originally with the water on the other side is removed. And that is where the problem is. Then the issue of lacto, about 90%. The 90% comes in from all the other rivers. Gongola has 10%. That is why your department ordered for a study to take some water from Gongola to Borno State. There's a study done by your department. Okay, you're no longer in dams. To take water from Hawol, because Gongola has the same amount of water coming into Benue from Gongola. It's the same quantity that comes in from Cameroon. You understand? So the other 90% comes from other tributaries: Donga, Taraba, Katinala, Dep, Mada. These things come with a lot of water because they are coming from all the highlands, as I was explaining you from the map I showed you, from either Jos Plateau or from Mambila Highlands. That's where the 90% is coming from. It's even more than 90% because a lot of them are trapped in the flood plains. In our flood report, we recommended that we should have detention basins. Even the National Council approved it for your department to do. Those detention basins are common in the Benue Valley. I think I've addressed the two questions.
Good afternoon, sir. My question, first, I want to appreciate our director. He has created the technical session for us. We have a review.
Please, we want to go for the tea break. Please, when we return, we'll take the question after the second presenter. So, those online, please, we will come back from tea break. We will take your question. Engineer Ade, please be ready. After the tea break, we will take your question. And then after the director and the resource person, please, they will go to the right side. While other participants, please, you go to the left-hand side.